The following presentation was recorded at the 2012 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2012 for helping make these videos possible.
With Red Hat, little company some of us know. He's now a sysadmin at a large academic research library at a small university in North Carolina. Does tinker with networks, as you'll discover in a moment. Once and almost forever, Kevin Otte.
It is interesting that Brian just happened to be the one proctoring this room for me, because he's actually one of my more avid workshop attendees. I've done a couple of workshops back in Durham for hands-on stuff, and he shows up with the whole monstrosity of a FreeBSD firewall and all the switches and everything. So we're really putting together the whole network here. So it was pretty fun. So, how does it feel to be living in the future? All right. So yes, the world IPv6 launch was 3 days ago on Wednesday, when all the major providers, Google, Yahoo, Microsoft, and all the big players, turned on IPv6 on their main services with the intent to leave it on now and forever. So, a little bit what we're going to go over, just sort of the features of what IPv6 is going to bring us. I'm going to go over just how the addressing works. You got to kind of know the basic vocabulary that you can work with to go forward. DNS issues, how we're going to manage being able to look up all this stuff. I want to go into a little bit of actual system configuration on some of the Linux platforms. And finally, if we've got enough time, just discuss briefly some of the applications level issues that we're going to run into. There's a lot here, so don't feel bad if you get overwhelmed. It is kind of like drinking from the fire hose. If you don't necessarily get everything, feel free to have some questions, or at least that way you'll know what to go look up. So, features of IPv6. It uses a 128-bit address space, as opposed to IPv4's 32 bits. So 2 to the 128th versus 2 to the 32, I will leave the obscene math as an exercise to the reader. But one comparison I saw to the two address spaces is if the IPv4 address space is the size of a golf ball, then the entirety of the IPv6 address space is the size of the sun. So we've got a little bit more room to grow. So hopefully we don't ever have to go through this again. Yeah.
What I heard said was that IPv6 every
Every person on planet Earth 1 times 10 to the 8th addresses. Yeah. Yeah, that's what I was saying. He was saying that one of the other aggregates was that whole notion of every person can have to themselves some obscene amount of addresses. At some point, when you get to that scale, it almost ceases to matter. You do want to be a little mindful of it, just because we don't want to go through this again. We don't want to get too willy-nilly. But on the other hand, the idea is you don't want to have to be renumbering a lot, like we're having to do right now. So the side effect of this is we don't have any more NAT. Hallelujah, yes. It breaks the... Yeah, how many of the application developers are loving this here? But network address translation has broken the end-to-end principle that the internet was originally designed around. And so that has caused a lot of headaches. I've seen the list of things the application developers have to do to be able to say, okay, well, I have to send this packet in this order and expect this reply to be able to know that I'm through both. No, none of that anymore. We'll still have to deal with firewalls, but that's a lot easier than actually, you at least know what the address is on the other end, and you know that's your endpoint.
I don't know where I'm sending packets.
Yes, it's like, on behalf of who? One of the features they put in is this notion of stateless address auto-configuration, or a SLAC. Basically, the idea is you don't have to use this, but they bake this in to make client deployments much easier. The idea is that the router advertises its prefix, its network prefix. The endpoint then creates its own network address, usually based on the MAC address on Ethernet, but it obviously doesn't have to be because not everything is Ethernet, generates this, checks to make sure it's in use, and moves on. So you don't have to have the statefulness of like a DHCP server. May end up needing it later. We can talk about that later if we have a chance. So let's go over how the addressing works. So this is your average IPv4 address, the dotted quad that we've all grown to know and love. This is your brain on IPv6. Yeah. So it looks pretty ugly at first glance, maybe a little apprehensive, but there are some ways to make this work a little easier. So the first thing that can happen is any of these leading zeros, I don't really have a good pointer here, but any of the leading zeros that are in the address can actually be lopped off. So you don't have to have all the digits in there if it starts with a 0. So okay, we've gotten ourselves a little shorter here. Now in this case, if you're assigning addresses to a server or a known fixed device, you may just want to assign it number 1. But who wants to be sitting there banging away at their 0 key all day? Okay, we don't have to do that. So in addition to the previous leader zeros can be stripped, anytime you have a single, this can only happen once in the address, but anytime you have a single long run of zeros, it can be shortened to this double colon notation. So this will mean fill in out to zeros to pad to what you would need. So suddenly this doesn't look quite so bad. Okay. Yes?
Would it make sense to just have the colons there without the zeros in there, so zeros are implicit, kind of like having optional fields in set classes?
So he's saying, would it make sense to have the colons there and just some of the zeros? You could just say colon 0, colon 0, colon 0, and just have the single 0. So that way you know that it's the whole thing. The leading 0 expansion rules do apply still. So you could have 12 colon 0, colon 0, colon 0, colon 1.
Well, I mean, having just, well, say there, you've got the 2 colons to represent the string
Yeah.
zero. Or you had 3 colons in there, so you've got the spaces separated. So
That's just not how the spec was written, unfortunately. I mean, there are some debate as to whether the whole notion of whether it's leading 0 or not, or whether you got the double colons. So, yeah, it's just basically a matter of that was kind of how it was designed to try and make it a little easier. Unfortunately, it does make the parsing rules kind of a pain. Somebody actually, just before I came down here to talk, sent me a regex that was to parse. I don't have that URL handy, unfortunately, but I think it was just word wrapped. It was something like 12 lines long. It was, wow. So in general, you're going to have the address split pretty much down the middle. Your first 64 bits are going to be your network identifier, and then the last 64 bits are always going to be your interface identifier. And so much like in IPv4, we used to have this notion of the classes and whatnot. V6 is totally classless, but they do tend to break it down on the colon boundaries, which I left out of here on the tabling. But basically, your largest IS allocations, usually to your ISPs, are going to be a /32. So you got that first DB8, or like Hurricane Electric, these guys are 2001:470. That whole thing is their address space, and they then carve out chunks from that. So a /48 would be then what you would give to perhaps an individual site. So like, for example, if Red Hat had a /32, each of their sites would probably be a /48, each of their different offices. And then inside those buildings, you'd have your site local aggregate, the SLA. And from there, then you would split out your /64s per VLAN, per subnet. There is a subnet mask. The slash notation is your subnet mask. It's just all done in CIDR notation because you don't want to be writing /FFFs:/FFFF:/FFFF, you know, for hours on end. But yeah, so these /48, 32, 48, 64, those are your slash notations. And those are your subnets, yes.
Do people subnet smaller than that, like they do in IPv4, or is that just going to go away?
So the question is, do people subnet smaller than a 64? Right now, no. 64 is kind of designed to be the last aggregate, especially because if you can use something smaller because it is classless, the router will gladly just mask it down to whatever it wants. But the stateless autoconfig won't work, and there's probably a few other things that have been kind of hard-coded not to work. There's some debate right now on whether you want to use a smaller notation like a 126 or a 127 on a router link, so you're not wasting all of that space. But right now, the current notation is to just use a 64 on any sort of interlink, on any link. And we'll get into link local here in a bit. Was there a question over here I thought I saw? No? Okay. How much a /64 would cost? That's mostly going to be your ISP, because right now for like a home ISP, I think the idea is you're going to actually get a prefix delegated to you from your ISP, and that'll just be par for the course. I'm hoping that's the case. So I want to go over some of the more notable addresses you'll run into. ::1, all zeros, 1. That is your Venerable Localhost. That's your equivalent to your 127.001 back in v4 land. So you'll see that on a lot of things that are listening localhost only, so that you can still talk to it like you would. Anything starting with an FE80, and this is what is known as a link local address. These addresses are only valid on the individual piece of wire or virtual wire in the case of wireless, but on that individual link. These addresses will never be routed. But these addresses are also used to pass a lot of the control messages. Gone are the days of things like ARP being a separate protocol. Most of all of that stuff is being done with ICMP-v6. So for those of you who've heard people say, don't block ICMP in v4 space because it breaks things, yeah, let me repeat that even louder in v6 space. You can't intercept ICMP and break it, or you will break a lot of things. Okay. But if you've done an interface list on any of your machines, you've seen FE80 addresses on all the interfaces. Every interface will get one right off the bat. Now you've noticed that : is used as the delimiter. And that's some confusion if, for example, you want to specify a port number. So the idea here is you want to wrap if you're using a bare address, then you wrap it in square brackets so that it knows that's the end of the address and that's your port number. Though you should be using DNS, which we will get into. Yeah, he's asking if it's true for browsers. Yeah, pretty much any app that's going to be parsing a URL or any kind of : notation port is going to use this bracket notation. In fact, that does, if you're looking at it from the security standpoint, that could open up a new vector for, somebody puts a bracket noted URL, much like they do bare URLs, v4 URLs, but not a great idea to be using URLs, especially because, okay, you've got a dotted quad out there, and I'll get into that later on. But basically, you have a dotted quad, you got a v6 server, you're not going to get anywhere. So now we have DNS, or I wrote it down in my journal so I wouldn't have to remember. Our standard A record that we're used to in v4 space. A record, address record. Well, since we're increasing the space by 4 times 32 is 128 bits, well, 4 times an A record is a quad A record. And that's our address type for v6 addresses. So, and you use the shortened notation, the system will expand it on the fly, and off you go. So forward lookups, pretty easy. So now we get into our reverse lookups. So again, you've got the sort of the reversed notation down there on the end where it's the last octet first coming back. Yeah. They went ahead and split it on the individual hex nibble boundary such that we could do finer grained delegation. Because if you notice in the v4, when you're trying to delegate on that last dotted address, you couldn't delegate anything smaller than a /24. So if your ISP gave you a 25, 26, 29, whatever, one of those small segments for your business, you had no way to actually delegate that DNS down. There was some trickery that got done, but there was no efficient way to do it. So that was the main impetus for doing this. But obviously, that's a lot to deal with. This is why scripts are your friend. Either scripts or database, some sort of automated method of dealing with this. But that's basically what the raw record's going to look like on the wire. Okay, so just a little break here. You can't go wrong with a cat, but this image was actually circulated at the European Regional Registry Conference a few months back, ahead of the launch day. But so now we'll get into a little bit on actually configuring your systems. So for servers, you're probably going to be doing mostly static type stuff. So we'll start with sort of the Red Hat based variants. And if I don't get to your specific flavor, I just went with the two biggest ones, the Red Hat and the Debians, just because that's most of what's out there. But obviously there's quite a plethora. So your main file is your etc sysconfig network, where it controls just sort of the actual core. Pretty simple. Add a single line, tell it, hey, we want v6. I believe in RHEL 6 and beyond, it's going to be on by default, but I think you need this for RHEL 5. Can't hurt to have it in there. And then you get to your interface. All the great stuff is what you've already got. You basically add an extra set of lines. And I was afraid I was going to do something like this. You do need the net mask out here. I forgot to include that, so you would have your /64. I think it will imply that, because I saw actually two different variants of this. But for safety's sake, you do want to put that net mask out there, so it knows to add that. And as I said, the Debian, Ubuntu, sort of the Debian base, all of their network stuff is handled in one file and is on by default. So you basically add another of the same interface, but you give it the INET6 family instead of the INET family. And you give it your address. The net mask is whatever the CIDR notation is, and you give it your gateway. So pretty simple going on there. So if you've been using the ifconfig command and the route command, I kind of recommend against kind of doing that going forward. The IP command is sort of what's being the de facto standard now, and it makes it you're able to get into a lot more guts of the stack, but it also gives you a more holistic kind of view of the interface. So your main commands you want to deal with are IP address show. That will show you all the addresses on the system. And then for this, you want IP-6, meaning the IPv6 address family route show. If you give an IP route show alone, it assumes v4. But IP address will show all of them. It is a little quirky. Firewalling. Everybody has IP tables running on their hosts so they don't get hit by the bad guys, right? So IP6 tables is basically the same command set. Obviously, there's no NAT table, but you do the same sort of input-output forward tables, and you can do the same sorts of things. So one of the things you may want to do is actually use the Linux box as a router. And I was mentioning in the bit about the stateless address autoconfig that the router advertises itself and its prefix. So you have something called router advertisement daemon, RADVD. This is the simplest config file that will get you up and running. There are a ton more options in terms of being able to tell it that go get your DNS information from over here, or take it from me on the router. That's an experimental feature. And in just terms of a bunch of whole other flags, timeouts you can set here. But this is the simplest one. It basically says, on this interface, yes, send advertisements. Here's the prefix. Let the clients automatically go for it.
Is this the part that enables what you talked about before, where IP addresses can be automatically assigned?
So you're asking, this is what enables the IP addresses to be automatically assigned. Yes, the stateless address autoconfig is baked into all the clients, but what happens is the router will, when it sends out, hey, I'm the router, there's actually a flag that says, you go automatically configure yourself, or don't, and use stateful. So there is still DHCP v6, and I didn't really get much into that here, but you can also, if you desire, have it say, don't auto-configure yourself, go talk to a DHCP server, get your address and your other stuff, but still use me as the router. DHCP v6 does not have, at present, the ability, as in v4, to say, here's your default route as well. There's some discussion about whether they want to add that, just because a lot of people are used to their workflow where the DHCP server does everything. But as it is right now, the way the spec is written, the router is sort of the canonical thing. This is how you get off your subnet, and it advertises itself, and then that's the negotiation on, okay, where do I get the rest of my information? Okay. So as I said, there are a lot of this has been sort of the OS level, sort of the dirt basic configuration, but obviously it presents some issues further up the stack into the applications. So as I was saying earlier, if you've got some kind of application, be it either XML or if you're sending back a web page, you have a link to a dotted quad address. Well, suppose now that we're exhausted on our IP addresses and somebody comes online, some distant part of the world, or maybe down the street someday soon, that machine does not have an IPv4 address. It does not have one. We don't have one to give you, sorry. And it comes across this and it says, well, I don't have a route to 192.168.17. Now what? So please, please, please use DNS entries wherever possible. Use host names. Because then what will happen is, for the time being while we're in this dual stack mode, while we have machines that have both the v4 and the v6, you'll get both the A and the quad A record back, and it will, the client system can then say, okay, I've got a route to this or both, and it can make the best decision as to what connectivity it has to be able to get back to your service. Of course, if it's only got an A record, you're still going to have the same problem, but at least it's a little more obvious what happened. So here's a fun little scenario we might run into. Suppose you've got a database that you're tracking customer IPs of some sort, and it's only got a 15-character limit because, hey, a dotted quad with maximum of 3 digits with the dots as a string, that's only 15 characters. Okay, what happens when you feed it this? I believe SQLite, it'll just accept it because I don't think it validates that stuff. MySQL, I think it just silently truncates it. Correct me if I'm wrong. And then you've got your Postgres, your Oracle, and some of your other engines. They're going to throw an error and flat out say, you tried to put something too big into this field, you're done. So there's going to be a lot of traipsing back through code to see what's going to happen and see where these things are. And maybe someone won't question the back. 1999 all over again, yes. Except the only problem, what? More work. Well, and the other problem here is there's no drop dead date. Like, we knew December 31st, 99, if this wasn't fixed, kaboom. This, there's just this shift. There's this slow migration. There's no one day. I mean, I don't know how many of you had to deal with the digital TV migration. They said on this day, the analog receiver or the analog transmitters are just going to go away. Unfortunately, there's no one day where it's like all the IPv4 on the planet is just going to go away. It can't really happen with billions of users on the planet. It's really difficult to coordinate one day. So that's why we had these events like IPv6 Day last year for a test run and IPv6 launch this year where it's like, okay, this is on now. This is the new normal. When you bring up new machines, they're v6. Or both, but preferably there's some kind of v6 on the machine now. So, any other questions from everyone? So the question is, the current stack of routers out there are pretty much all v4, and are we going to see updates? And that's a big, huge it depends. A lot of those older routers, they've been end-of-lifed by their vendor, or their manufacturer. So they're probably not interested in going back and getting new firmware ported to them. And of course, it's like, well, of course you're going to give us more money for buying a new product so that you can get on the new internet. And unfortunately, that may be a lot of what happens. In terms of the open source world, you can get an alternate firmware like OpenWRT today. I think DDWRT is working on it, your PF Senses, all of those firmware projects that you can flash on. But in terms of the average consumer, yeah, they're probably not going to be there right yet. Yeah. So in your case, you have AT&T Uverse, and you've got their router box, and that's the only option. So it's incumbent upon them to then, when it comes time, they have to give you a new router box. But that's the joy and the curse of being able to have that, is because it's their problem. So I had back here, and then you.
I think that my question is, how willing do the ISPs seem to adopt this?
That's another one of those, it varies. There are some ISPs out there that kind of have their head down in the sand. It's like, oh, well, we don't want to spend all this money right now, and it's just, that's just a thing. And IPv4 is not going anywhere, so clearly, But unfortunately, the flip side of that is the only other way to get around this problem is if you've got more and more and more clients coming online and you don't have addresses to give them, you got to start putting them behind layers and more layers and more layers of NAT. And so it becomes more difficult for them to have to engineer all of that stuff in between, when they could just say, well, you know what? Why don't we just spend all that money and migrate to IPv6? So some of the ISPs are getting that message. Some of them are still waiting till the last possible second so they can turn it in like a really bad term paper. You and then you.
Just to follow up, I've got Uverse at home, and what I did is I went to Hurricane Electric. I noticed your shirt, by the way. It looks nice. Hurricane Electric will provide you with IPv6 tunnels.
So he's noting that in the same situation where you've got Uverse, and so right now, yes, you can go to a tunnel broker. I personally use tunnelbroker.net in terms of the easiest to set up. And yes, you can still set up a tunnel. Now, since you don't have control of the end device, you're actually setting up that tunnel just a hair inside. You're still going out through the NAT. It gets a little dicey. It can be done. But ultimately, we need to get the ISPs on board with the fact that we need to do this. Actually, we had him next. Okay. So Teredo is the protocol, and Moredo is a client you can install. That's what I consider sort of the protocol of last resort for migration, just because you do have to install it on every single client. You only get one address, and it, as well as 6-to-4, is another migration strategy, but those are what they call anycast. You're sending all your traffic to 192.88.99.1. Doesn't matter where you are on the planet, you send it to that address. And then the intervening routers figure out where the nearest gateway is for you automatically, which means you don't know. So if you're trying to troubleshoot a problem and you're trying to figure out where that gateway is, that doesn't necessarily always work. And it could just change out from under you in the middle of the stream. So it makes life very interesting. Oh, go ahead.
Our shop's a built BSD shop, and I got talking about this conversion for a while. You want, like, my guys keep on saying in the community saying that there's a lot of security risks that goes with this.
So the question is, you've got a lot of OpenBSD, and they're very concerned about the security risks. That is such a murky topic. I'm not a security professional, and I don't really know if I'm trained to speak on such things. But it is, to my mind, it's really no more or less secure as a protocol than v4, because at some point it's just telling where the bits go. The problems start to come in where you have these migration strategies. I know in the case of Windows, a lot of them have, if it detects that you have a public v4 address, it will turn on 6-to-4 automatically. Or if you're behind a firewall on some of the client OSs, it will turn on Teredo automatically. Which is handy because then if you have a site that's v6 only, so as these servers start to come online that they can't get v4 space from their ISPs because they've just plumb run out, then this client that's v4 only has a mechanism to tunnel and get there. But now your malware has another way to bypass the firewalls and tunnel back out. Whereas with your v4 border policies, you may have firewall rules in place to say, okay, that's bad traffic, but if it's encapsulated inside a UDP frame that it doesn't know about, it might get through. So yeah, the migration strategies present their own unique security issues, but with any luck, their time is hopefully limited.
Question. It's my impression that NAT kind of forces a star configuration for networks to a degree. And that provides providers with a great deal of control. I'm wondering, the IPv6 threaten that?
So the question is could IPv6 threaten the sort of ISP level control by forcing everything through the NAT or through the central routing point? And well, yes. And that could be some of why ISPs are a little scared of it, and some enforcement agencies, your providers just don't want, they want to control you, essentially. And yeah, the whole notion of the internet when it was created was an end-to-end principle. I can talk to anyone, any machine on the planet as a peer. And now that there's these new business models that have cropped up where it's, consumer, provider, consumer, yeah, there is some of that. But that gets more political. But in terms of, it makes the technical jobs a lot easier.
From a cost management perspective, how long are we thinking that we could stay on IP? Like, when's the last day that means, like, say, by this time, like, we should be over on IPv6? Because I mean, like, this has been, what, like 10 years?
Yeah, so the question is, by what day do I need to have all my v6 working? In my opinion, a year ago. That's what I was commenting earlier, is that there's no drop dead date. There's no way to kind of enforce.
Well, I guess maybe the question would be, like, when do you think that there's going to be, like, massive, like, more density to actually say this? Like,
So when do we get more density on v6? When do we get more usership, more network effect to make it viable?
right.
That's the problem, is that's been a lot of opinion. I think with the World IPv6 launch this past Wednesday, that is a huge driver. So you now have a lot of content providers. 3,000 of some of the major sites on the net are now providing v6 in the clear. Because one of the things prior to launch day was Google had a whitelist. If you said to them, we have known working v6, please accept any DNS requests from us and give us Quad A records. They did that because they didn't want misconfigured sites to not be able to reach Google, because the client is not going to assume that it's the ISP's fault. They're going to assume Google's fallen off the map. But now we're in a whole new world. v6 is the new normal. So please go turn it on as soon as you can. Even if it's just in your test lab right now, to get used to it. But you want to be comfortable with it. You want to do it on your own schedule so that you're not freaking out at the last minute like that bad term paper. You want to have a very good grasp of the fundamentals, and you want to have hands-on experience with it. So, go home, set up a test lab, or, set something up on the side in your business with some addresses. And I'll bet you that you get very familiar with it very quickly and go, this was easy. And then you can start an actual rollout plan.
The broadcast and the multicast,
Question is broadcast versus multicast.
I mean, in my IPv4, there are special ranges of IPs.
So the question is there multicast essentially in v6 space? So broadcast is gone. There is no more notion of a broadcast to your link. Everything is considered multicast. There are certain multicast addresses. I don't have a list of them here, but you can go find the relevant RFC. But anything starting with that F digit means this is a multicast address. So you can have site-wide multicast, and there is, sort of local multicast that acts as a broadcast. But the whole notion of a broadcast specifically is kind of gone away. But you have your variable multicast scopes. And a lot of the router advertisements, the neighbor discovery, which is the equivalent to your ARP, that's all done over ICMPv6 to the multicast scope for your link.
Just as a follow-up to a former thing, could you talk about the idea of dual stack,
So-
4 and 6, and then the idea of that if you have hardware that currently doesn't support IPv4, that's
Or v6, you mean? So the question is, the whole notion of dual stack, and you're saying, if you've got a machine that doesn't support going to V6, yeah, yeah, right.
So the idea is that during the transition time, you want to have both 4 ends.
Right. So yeah, during this transition, you want to have both your V4 and your V6 stack, especially on your servers and your clients as well, so you can still get to some of the legacy stuff. But yeah, eventually there's just going to be services out there, and some ISPs now, especially in the Asia Pacific. They were the first to run out. So your option for getting V4 is, yeah, you're going to have to continue to either do network address translation out to other V4, but there's no way to translate up to V6 because you can't cram 128 gallons into a 32-gallon bucket. So you're probably going to have to do some application level stuff. You're going to have HTTP proxies, you're going to have IMAP proxies, you're going to have all these sort of different proxies for these devices that are still legacy that you just can't ever upgrade. But as time progresses, you're probably going to get into a situation where you had a lot of those devices that only ever spoke IPX. How many of those are still out there? A few, granted, but they're very rare.
Will it end up that every device has a permanent address, like based on the MAC address and serial number or something like that?
So he's asking if it'll end up whether every device will have a permanent address based on a MAC or serial or something like that. Probably not. I mean, you've still got the whole notion of you can still do DHCP, and those will be handed out for a short time. That's mostly a lot for compliance and security tracking. Stateless address autoconfig is based on the MAC address, and I can actually show that a little here. So the router says hello. Here's my prefix, and like I said, the experimental feature of putting the DNS resolvers in. But what it actually does is it takes the MAC and converts it to this notion of an EUI64. So you have to switch one of the bits in the first octet, because that determines whether it was locally generated or globally generated. So whether it was assigned by a vendor or whether it's just something you picked up off the shelf. And it inserts this flag to make it enough bits. Some people saw this and said, wait a minute, there's a privacy concern here. Even if my prefix is changing, if I go from network to network to network, and I'm still essentially advertising my MAC address, that's a unique identifier that they could use to identify me. They don't even need cookies at that point. I said, okay, that's fair. There is this notion called privacy extensions, wherein it can still generate this address mostly for the on-link traffic, but then what it will also do is generate a temporary, what essentially amounts to a random number. And it can also then rotate this through every desired interval. I think it's every hour it reassigns. So that you can use that for outgoing connections, and they can't track you if it comes back and who owned that IP, we don't know. No, the client is actually what's doing the reassignment of those IPs when you're in Slack. So the privacy concerns are now mitigated because it's generating a random number. But the reason, at UNC, when we're trying to roll this out, we can't use that. We can't really let that go because one of our security policies is that we have to be able to say, okay, someone has done something bad. It occurred at this timestamp and it came from this IP. We need to be able to take those 2 bits of information, go back through whatever mechanism we have. In our case, it's a lot of logs and DHCP server matching to be able to say, okay, that's the person who had that IP at that time. We will have a chat with them. This breaks all that, so we can't roll this out. And the DHCP v6 doesn't use the notion of a MAC address. The DUID, you could go hours on that. So long story short, we don't have an answer for that yet. And it's very frustrating, which is why we haven't rolled this out to the clients yet. Yeah. Well, the client could change its MAC address, and the client could actually just, obviously there's a much larger space, 2 to the 64, to just pick a random address from. So in theory, yes, that could happen, and you could do that in V4 now. I think they said, the networking office said the number of times they've seen that in the last 10 years has been 0. So admittedly, it is kind of to keep the honest people honest, but it's been good enough for compliance purposes to be able to have that track back in terms of timestamp, IP, person. It's just unfortunately we don't have a good clean pathway for that yet. for v6. There's some notion of using 802.1x for port level authentication, but not everything has a supplicant. You know, if you've had to deal with any Windows clients, their supplicant support is hit or miss. So you get into a lot of those issues. So we're trying to come up with some system that is generic enough that all the OSs can get on. The user has to do a minimal amount, if any, interaction. Because right now we basically have them go to a web page, register their MAC address before they can get onto the system. But we're just unfortunately not there yet.
Explain a little bit more about how we break up networks and with firewalls. Now, if I have my private network, I actually don't want people necessarily getting my computer for any reason whatsoever. With IPv6, I'm now almost like a flat network.
Right. So the question is, how do you do firewalls and sort of the notion of keeping with right now you've got NAT. You've got a address space that is never routed. Well, the good news is your firewall, that route point will still be there. It will just serve as a firewall. Instead of translating the addresses, you can still inspect the packets as they come by because it's still a routing decision. So you can say, this chunk of my space, only allow these ports, or this chunk of my space, don't even allow. And don't even allow anything in, only allow my outbound and any related traffic, because you can still do the stateful packet inspection. That's what really makes it so powerful. That's that jump, allow, established related, I think it is in IP tables. You can still do that in v6. You can have a network that says only let clients go out and only process their answers. So you still got that same level of the statefulness that it has, but you're still able to then see the endpoints very easily. You don't have to look at a translation table. So you don't have to just worry about port forwarding. You can basically say at the border, allow these ports if you want. You don't have to forward them. You just say allow them through.
Does this one config network? Wait, not network, firewall. IP tables? I forget the name of the Red Hat.
On the Red Hat, it's etc sysconfig IP tables. I think etc sysconfig IP6 tables is there, but I'm not entirely certain.
Yeah. Well, I meant the program that configures it. I believe it's system config.
Oh, the sort of assistive tool? Yeah, so you have system config. I think it's actually a system config firewall, now that I think about it.
Yeah.
System config firewall. I'm not sure. I haven't actually tried it. We should do that sometime.
The other question is, do you have any advice for a good fire or IP tables generator?
Advice for a good IP tables generator. I don't. I'm a bit of a purist. I like to actually muck around with the IP tables. I know our lug on our services uses Shorewall. And I have gone in there and set up the equivalent v6 rules once we brought up our tunneled connectivity. So there is enough parity there. Basically, if you have one that's you're familiar with, that you're comfortable with in v4, just go see if they have v6 support. And if they don't, maybe you can encourage them to kind of bring that along.
Let's say a contact center where just was reading the supposedly support on some of their subscribers. I changed over to IPv6. Who does the gateway to IPv4 for those websites and services?
So the question is, if you call Time Warner, you get your v6 address, and they turn it on, and who does the gatewaying? Well, in Time Warner's case, with any luck, they're going to give you dual stack. So you're still going to have both a public v4 address that you'll still be able to NAT through like you already do, and you'll have your v6 that you can then route through. Now, in the case of T-Mobile, their v6 trials, because of the way 3G works, you can only have one address, either a v4 or a v6. There is actually a mechanism where T-Mobile has done this, a couple other sites have done this, where there is a NAT 6.4. So if you're a v6 only, they basically map the entire IPv4 space into the last 32 octets of the address space here. So they basically take these last bits and represent the IPv4 address as hex. And then the trick they have to be able to do to be able to pull this off is you have to use their DNS resolver. So when it makes the DNS request for a quad A record, it then goes out and asks. And if it only gets back an A record, it takes that IP address, responds with the 32-bit encoded address with their address space as a quad A record. And then your machine happily makes the connection. And for about 99% of your applications, actually it works pretty nicely. I've done some test trials of this on my test nets at home and it works great. There are some caveats, things like Skype and I guess some of the other voice over IP, any sort of direct link tools, they like to encode the dotted quads. So you may be able to do a DNS resolution of the sort of handover point, and you can get connected to that, and then it says, okay, go talk to 1.2.3.4. Well, you try and open up a socket connection to 1.2.3.4, you don't have a route, you're right back to that. And of course, since you only think you have a v6 address, yeah, you can get to v4 if you know to do 2001 db8, C00002FF or whatever. But the application doesn't have that level of knowledge.
So realistically speaking, it's really going to be a long time before we can actually turn off IPv4.
Realistically speaking, yes, it's going to be quite a while yet before we can actually have a pure v6 system. I know somebody mentioned BSD. There's even some issues with even the local loop machines. FreeBSD, the reason I bring that up is they have actually started to do trials with a kernel that does not have any IPv4 compiled into it whatsoever, just to see how it's going to behave, because someday this will be the norm, but they've already started that work. But I know I have some of my various daemons even on my Linode. They're compiled to listen to 127.0.1 and only 127.0.1. They don't have the ability to bind to : Perl, I'm looking at you.
Are there things like printers which will, as long as they exist, IPv4 will be needed?
So he's asking about things like printers, other embedded devices. Yeah, you're going to have devices out there that only have an embedded v4 stack. That's the joys of working with it. But even our phones, because the IP stack is down essentially right next to the radio firmware, my phone cannot get a v6 address, even though T-Mobile has the support on their network, just because the radio just has no knowledge of it. So you're going to have a lot of things where maybe you can get some kind of a firmware upgrade from your vendor, hopefully, maybe. But yeah, you're going to have a lot of things out there that are just still v4 forever. So you're probably still going to have a lot of private space. You're going to have to do some kind of application level proxy or get new hardware, which I'm sure the vendors are loving because that means you get to spend more money with them. But yeah, who has that kind of money in this economy? All right.
So what's the next event? So there's more launch day, and there's
Well, launch day was pretty much the last one I've heard of, and it's so it's basically saying this is the new normal. So the next event is you go home and you go turn it on.
Is there going to be like an IPv4 turn off for an hour day and just the world?
Is there going to be an IPv4 turn off? I would love to see that. I think that would be a really fun exercise. I don't know. I really don't know if there's going to be any such thing. We're just still really trying to convince people that, go turn this on. Go see how it's going to be. So are we about out of time? No, we can keep going. All right. Got about 10 minutes. Any other questions? Or I know it's coming up to lunchtime. If you guys want to go get some food, I understand. All right. Thank you all so much for coming.
Thank you, Kevin. Now, just before everybody hits the road,
cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers, then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler and faster and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.